Hi, today I'll be teaching you how to compute a machine problem with the use of CPU scheduling algorithm of round robin. But first, let's define what is round robin. Round robin is a preemptive version of FCFS algorithm. The one that enters the ready queue first gets to be executed by the CPU first, but is given a time limit. This limit is called time slice, which process will enter the rear of the queue after its time slice expires. We have here a sample machine problem with process ID and their respective arrival times and CPU bursts. To start, process A arrives at the ready queue at 0 and will start executing at 02. At time of 3, process B arrived, so we will put it in the ready queue. And at the same time, process A consumes its first time splice. So, we will put process A back to the ready queue again, since process A still have remaining 5 CPU bursts. Process B and process A are inside the ready queue. By the time process A finishes executing at 3, the CPU will select process B to execute next. Process B will start execute at time of 3. Since nothing arrives while B is executing, the B got to finish its CPU burst of 1. Next, since process B is done and only process A is left at the ready queue, process A will start to execute. A will start at time of 4. While executing, process C arrives at time of 6. So, we'll put it at the ready queue. Then, process A stopped at time of 7, consuming its second time slice. And since A still have remaining CPU bursts of 2, A will still go back to ready queue following process C. Process C and process A inside the ready queue. The CPU will select C to execute next. Process C will start execute at 7 at time of 8. Process D arrives, so we will put it at the ready queue. Process C continued until stopped at the time of 10, consuming its time slice and CPU burst. The time the process C stopped, process E also arrives, so we will put it also at the ready queue. We now have 3 processes left at the ready queue, process A, D, and E. Since this is a preemptive type of FCFS or first come first serve algorithm, we will execute who came first among them 3. So, it will be process A, with the remaining CPU burst of 2. Process A will start execute at 10, consuming its CPU burst, so it stopped at time of 12. Next to execute is process D. Process D will start at time of 12, and since process D has 2 CPU bursts only, it will stop at time of 14. Now, the only process left at the ready queue is process E. So, process E will be the last to be processed. Process E will start to execute at time of 14, consuming its CPU burst. Process E stopped at 17. Take note that time splice will only use when the CPU burst is more than the value of time splice. To calculate the waiting time, let's list down the arrival time of each process. At the left side of it, we will indicate the time they start to execute. In process A, since it executes 3 times, it will be subtracted 3 times 2. Adding the difference will be the process A's waiting time. So, since process A first execution start at 0, we will subtract it to the arrival time of A. Then, adding to the result of 4, which is the time process A start to the second execution. Subtract to the time where process A first stopped, which is 3. Adding again the difference to 10, which is the time where process A execute at the third time Then subtract to 7, which is the second time process A stopped to execute. So, 0 minus 0 is 0, plus 4 minus 3 is 1, plus 10 minus 7 is 3. 0 plus 1 plus 3 is 4. That's why it is 4. Then process B start at time of 3 and its arrival time is 3 too. So 3 minus 3 is 0. Process C start at time of 7, subtract to its arrival time of 6, so 7 minus 6 is 1. Process D start at time of 12, subtract to its arrival time of 8, so 12 minus 8 is 4. Process E start at time of 14, subtract it to the arrival time of 10, so 14 minus 10 is 4. Adding all of them, 4 plus 0 plus 1 plus 4 plus 4, the average waiting time is 13. Calculating the turnaround time, listing the arrival time of each process again, we will minus 8 to the time they finish to execute. In the condition of A, which executed 3 times, the last time is A stopped to execute is what we will get. The technique that taught to us is that just look at the right side of each process. The first number at the right side of the process is what we need. So, in process A, it is 12. Minus the arrival time of 0, the difference is 12. In process B is 4 since minus the arrival time of 3 equals to 1. Process C is 10 minus to the arrival time of 6 equals to 4. Process D is 14 minus to the arrival time of 8 equals to 6. And process E is 17 minus to the arrival time of 10 equals to 7. Adding them is 12 plus 1 plus 4 plus 6 plus 7 will sum of 30. And that is why the average turnaround time is 30. So that's it. I hope you understand this video. Thank you. Bye.